All right, and then let's try another one. Okay, for example, here we go. Let's say that my set B is going to equal the set of, this notation changes a little bit, so I want to get you comfortable with both types of notation. B is equal to the set of 12 times n, so that n is an integer. So this kind of reverses the part before the colon and after the colon. It's okay, it's still the same process. Sometimes we put what the element is supposed to look like before the colon instead of after it. These are both valid ways of writing set theory notation, and I want to get you comfortable with both. And what we want to do is prove that little b equals 36, that's the one that I'm giving you, lives in capital B. So, two things to deal with. We need to show that little b looks like 12 times something, and that we need to show that something lives in n. So here's our proof. Part number 1, we need to show that b equals 12 times n. That's our first part. So obviously, clearly, we'll go with clearly, b is equal to 36, and that's 12 times 3, which is going to be 12 times n, where n is equal to 3. So I've got the part before the colon. My 36 looks like it's supposed to. My 36 looks like 12 times something, and my something is 3 in this case. The second part that I need to show is I need to show that my n lives in the integers. And this is the n that I came up with in the previous step. The n that I came up with in the previous step is 3. And so this again can be clearly n equals 3, which lives in the integers. No problem. We've dealt with the part before the colon, that's step 1. We've dealt with the part after the colon, that's step 2. And so we can say, therefore, little b, which is 36, lives in capital B as desired. Okay. So again, this is one where the steps kind of sort of get flipped because the defining characteristic, what the element is supposed to look like, is before the colon instead of the after the colon. So in this one, I'm going to call it the defining characteristic. 12 times n is the defining characteristic for what elements in this set are supposed to look like. It's kind of the definition. Characteristic. Defining characteristic of what elements in here are supposed to look like. For even numbers, the defining characteristic is 2 times something. For odd numbers, the defining characteristic is 2 times something plus 1. In our previous example, the defining characteristic would be x squared minus 1 is even. That's my defining characteristic. So my element looks like, my element is something where x squared minus 1 is even. Defining characteristic. That's what you're looking for these types of proofs. Okay. Anything for questions at this point? How we doing? Give me a thumbs up. Making sense? Good. Yes. Okay. I'm going to put you into breakout rooms and I'm going to have you try one. So let's put the next example up here. For example, let's let my set capital C equal the set of 4n plus 5 so that n lives in the integers. So this is like the second one where a defining characteristic comes before the colon instead of after. So my set is 4n plus 5 so that n lives in the integers. And what I want to prove is that little c, which is going to equal 9 in this case, lives in my set capital C. So we want to prove that little c, which equals 9, lives in my set capital C in this case. So capital C is 4n plus 5 so that n lives in the integers. Everybody got this one written down? Okay, all right, I'm gonna do breakout rooms here. I think we're gonna do guys and girls just because, and then I'll let you guys talk through this one. So, all right. You should get an invite to breakout room. Go ahead, talk through that one. Don't just do it on your own, but talk through it with other people, please and thank you. Go ahead.